This lesson is on comparing and ordering numbers in scientific notation. You should have your foldable is one-sided. Go ahead and make sure you cut along the outside dotted line. And then what I did is folded and then made slits along the dotted line on the inside so that then I have 4 flaps that I can open. Don't cut all the way because then you won't be able to glue anything down. All right. Then I'm going to go ahead and glue this outside flap, this very outside edge, I should say. Okay, just the very outside edge. I'm going to glue down. So now I have flaps that I can fold up and right underneath. Okay, and we're going to start with number 1. Which number is greater? So here I'm comparing my numbers. Okay, well, the first thing that we're going to want to look at, okay, so on the inside flap, when the powers of 10 are the same, compare the digits. Okay, so the powers of 10 are this 10 to the -4th and the 10 to the -4th. They are the same. Okay, so then let's look here. We have 8 times 10 to the -4th. Well, let's see what that actually looks like in standard form. It's actually 8, and I'm going to move my decimal point to the left because it's -4 spaces. 1, 2, 3, 4. So this is my number. Okay? And then I also had the 9 times 10 to the -4th power. So I'm going to move my decimal, put this in standard form or standard notation, going to the left 4 spaces. Okay? So I have 0.0009. Well, which number is bigger? Would you rather this much of a penny or that much of a penny? This is obviously greater. So you're going to write your number back in that standard form. 9 times 10 to the -4th power is greater. Okay. Example 2. Okay, this says, which number is greater? Let's look at it like this. Okay, we have 5 87/100 times 10 to the 5th power, and then we have 58,700. Well, notice first that these two numbers aren't in the same form, so we're going to need to make sure that we put our numbers in the same format. Okay, so on the inside of the flap, we're going to write when the digits are the same. Okay, so now the digits are the same, not the powers. Use the quotient rule. On the powers of 10. And then write your answer in standard form. Okay. All right, so our example for that, we have the 5 87/100 times 10 to the 5th power. And then we have 1,700. All right, we're going to put the numbers in the same format so that I can compare them. It's going to be much easier for me to see if they are, which one is greater if it's in standard form. So let's go ahead. We have this 5.87 is my digit, okay? And we're going to look at, let's put this in standard form, we're moving to the right because it's a positive exponent with my power of 10, 5 spaces. 1, 2, 3, 4, and 5. Okay? So then I actually have 587,000 is what that number looks like. And then this is this was the second option, 58,700. Well, which number is actually greater? I'd rather have this much money than that much money. Okay? And it said to write our answer in standard form. This is standard form already, so let's just rewrite it because this number is much greater. Example 3. How many times larger is 2 times 10 to the 9th power than 2 times 10 to the 6th power? Okay. So on the inside of the flap, we notice here that the powers are different, okay, but those digits are the same. So when the powers of 10 are different, compare the exponents. Okay, so let's look at that. We actually have then 2 times 10 to the 9th and 2 times 10 to the 6th. All right, well, when it says how many times larger is it, we're looking just at the exponents. We have that same digit, okay? So technically we're dividing how many times larger. So we have that 2 times 10 to the 9th divided by 2 times 10 to the 6th. Well, the only thing here that I'm really worried about is the exponents of the power. So I actually have, well, use your division rule or your quotient rule. We really have 1 times 10 to the, my division rule here with the exponent is to subtract. 9 minus 6 is 3. So we have 1 times 10 to that 3rd power. That's how many times larger. Okay? And example 4. We have how many times larger is this 4 times 10 to the negative 3rd than 2 times 10 to the negative 6th. Okay? So notice that the digits are different, okay, and those powers are different. So we're going to start on the flap, sorry. When the digits are different, divide the digits, just like we did a minute ago. Then use the quotient rule. For exponents on the power of 10. Write your answer in standard form. Okay, so we have, for example, 4 times 10 to the negative 3rd. And we said we're dividing it by the 2 times 10 to the negative 6th. The question was, how many times larger is it? So I already know this is larger, so it's going to go on top. Okay? We're going to use the division rule. Divide your digits. 2 goes into 4 2 times. We need a power of 10. And our division rule is to subtract the exponents. So minus -6. Keep change. -3 plus 6 is +3. So our exponent is +3. But then my flap told me that I need to write my answer in standard form. Okay, I'm going to use my digit of 2, and I'm moving my decimal to the right 3 spaces. I know it's going to the right because it is a positive exponent. So let's go 1, 2, and 3. Fill in your zeros. So my answer is 2,000. Okay, that number is 2,000 times bigger. So now what we're going to do is look at the left-hand page. I'm going to do 2 of them with you. Okay, this is your left-hand page that goes with comparing and ordering numbers in scientific notation. All right, let's look at number 1. I need a pen. Okay, so the mass of the sun is 2 times 10 to the 30th power kilograms. The mass of the earth is 6 times 10 to the 24th kilograms. How many times bigger is the sun than the earth? Well, we know they just told us that the sun is bigger than the earth. Also, we know that just as to be fact. So the sun, the mass of the sun is 2 times 10 to the 30th power. And then we're going to divide it by the mass of the earth, which is 6 times 10 to the 24th power. Well, all we needed to do was divide the digits. 2 divided by 6 is 1/3, or 0.3. And it is 0.3 repeating, but we're going to just call it 0.3. And then times 10, we need to subtract our exponents. So we have to the 6th power. This is not scientific notation because my number is not between 1 and 10. When I move the decimal to the right, I'm going to subtract a number. That's a small number, so I'm going to have to remember to subtract to fix my exponent. So my answer is 3 times 10 to the 5th power. That's how much bigger the sun is. That's how many times bigger the sun is than the earth. And number 2. In 1974, a computer could complete 3 times 10 to the 8th computations per second. In 2011, the computer could complete 1 times 10 to the 16th computations per second. How many times faster in the 2011 computer than the 1974 computer? Express your answer in standard form. Okay, we already said that the 2011 computer is faster, so put that on top. 1 times 10 to the 16th power. And we're going to divide that by the computations per second for the computer from 1974. 3 times 10 to the 8th. We're going to do the same thing. Divide your digits. 1 divided by 3 is 0.3, and it is 0.3 repeating, but we're going to keep it as 0.3. And then we're going to subtract the exponents. So it's times 10 to the 8th. This is not in scientific notation. I need to move my decimal over just 1 space, so I'm going to subtract a 1. Since I moved it to the right, or since 0.3 is a small number, I move it to the right to fix it. 3 times 10 to the 7th power. It says to express it in standard form, so it's actually 3, and I'm moving 7 places. 1, 2, 3, 4, 5, 6, 7. Fill in your zeros. So 3. 30 million. It's actually computes, or 30 million times faster. Go ahead and finish this for homework and turn in the left-hand page when you come to class. So glue everything else in and leave this blank. The code word for this lesson is ladybug. So go ahead and make sure you get this done. Your code word is ladybug. If you have any questions, as always, email me or send me a remind text.